This is the floating balls experiment. Now for the floating balls experiment, the balls we're actually going to be using are ping pong balls. And as you can see, I've got a few different colours here. You can try slightly different sizes, but of course most ping pong balls come in about the same size. I'm going to use this one because I like it. You do need a hairdryer. Now of course be sensible, we're using electricity, but many people use hairdryers at home. Just be sensible as you would if you were using it at home. I want you to take your hairdryer, I want you to hold it gently, but nice and still if you can, and point it straight up in the air, okay? So straight as you can, like I'm holding this one. I want you to switch it on, and when it's on, I want you to take the ball, hold it above, you'll feel the air blowing past your fingers and thumb, and then just gently let go of the ball as if you were dropping it down onto the top of the hairdryer and see what happens. Okay, if you did the experiment as I wanted you to do, this is what you should have noticed. Okay? So what's going on? How can the hairdryer keep the ball floating in the air as you saw it doing it? Lots of the science on this you're going to find pretty easy to understand. For example, you know the air is coming up from the hairdryer. You know it must be hitting the ball from underneath, keeping it in the air. So most people can understand very easily that the air from the hairdryer is blowing up and pushing on the ball and keeping it at a certain height. But an interesting question is, how come it doesn't fall out of the airstream? Because lots of people think it should, it will just blow it away. Well, you saw it stays there very easily. Well, I'm going to have to ask you to use your imagination a bit here, because what I want you to think about, you can't see. The air, of course, is flowing, which you can't see, because it's invisible, it's see-through. The air towards the middle of the air that's blowing up in the air blowing here is going pretty fast. The further we get away from the middle, the air goes slower and slower. Fast flowing air doesn't push as hard when it flows past something as slower moving air. So when the ball is in the airstream, the air is blowing up past it, and the fast air that's blowing very close to the ball and whizzing around it doesn't push very hard on the ball compared to the air which is further out. Because that air is further away from the ball, but it does push still. And every time the ball moves a little bit to the side, it meets that slower moving air further out, and that slower moving air pushes a bit harder, but pushes it back in again. Now you're going to see this. If I do this again, I want you to watch very carefully, and you'll notice the ball is wobbling. Only a bit, but you can see it wobbling as it's moving away from the centre of the stream of air towards the slower moving air, but then it gets pushed back. Watch again. Now, something else you might try. I'm going to put this back in the airstream again in a second, but I'm going to tip this hairdryer slowly, slowly, slowly sideways. Turn it around. Now I'm going to just do it a small amount. But of course, if you do this, one question I'm sure some of you are thinking is, I wonder how far I could tip it before it falls. So that's something you can try. So, do you think you could now do this with the hairdryer moving around while trying to keep the ball in the air? Remember, you'd switch it on, you'll have the ball here, and then move the hairdryer around. Do you think you can do that and keep the ball in the air? Do you think that you'll be able to move it at a certain speed, but if you go too fast it won't work? These are some things for you to try, and I'm sure you can think of some other things too. A real life example of the science behind the experiment involving the levitating balloons and the floating ping pong ball could be seen, for example, in something called a Boyle's machine. Now this is a machine which anaesthetists use in operations. And basically a part of the machine has some little flow meters where the gases which are being given to the patient flow through. And the anaesthetist controls this by a little dial, and they can make the flow change by turning the dial, and they know the flow has changed because there's a little ball in the tube that the gas is flowing through. And the higher the flow rate, the higher the ball goes up in the tube and lines up with some little markings on the side of the tube. The lower the flow rate, the little ball comes down and of course therefore lines up with a lower scale on the tube.